Today we're going to be talking about water treatment technologies that might be applicable to your project. I'm going to briefly cover different treatment technologies that might be applicable for Vanuatu, but keep in mind that these are not all the technologies that are available out there, so you need to do your own research. There is also not one single correct answer, but often several correct answers, and you may need to use a lot of these technologies in a series to complete the treatment to the required standard that the project needs. If you're stuck, these technologies will be a good place to start your research, perhaps using them as keywords for journals and databases on the UQ Library website. So the first one I'm talking about is filtration, and this is similar to what you would do at home using a sieve. It's simple and it's great for communities with the lower education, but it does require cleaning. So that means you've got to think about how would you clean the filtered stuff out, how often would you do it, and what happens if the stuff you filtered out is pathogenic or dangerous to touch, who's going to do it then? Here's a filtration unit used at an industry. Now you'll see filters are often used as a multi-layered system, meaning there's different components that filter out different things. We do this because it's more efficient, and it does save on cleaning costs as well. So the first layer, for example, might filter out leaves, so the bottom layer doesn't have to, because that first layer might be a lot cheaper, and it might be a lot easier to remove as well. The next one is coagulation and sedimentation. So coagulation and sedimentation clumps up particles, binds it all together, and then removes it as a bulk. If you want to use coagulation, you've got to consider where you would get the coagulant to add in, and is it available for an island community such as East Santo? In coagulation, there's also another stage to it, that's the flocculation step as well. So the coagulation step actually destabilizes the particles, and the flocculation step makes it clump up so you can remove it. Now, if you're going to do this, you might think back to podcast 1. We do this sort of coagulation step because it removes turbidity. And turbidity is quite important because it affects the taste of that water. People don't want to drink bad tasting water. Now, there's also the case for removing turbidity because it actually makes downstream processes, that's processed afterwards, a lot more efficient because there's less turbidity in that water. Distillation should be familiar to you. It's similar to boiling a kettle at home, but with key differences. So one of those differences is you're actually collecting the steam that boils off and you're condensing it. This does mean that the water you produce is a lot more pure than you would than what is obtainable out of a kettle. If you remember back to podcast 1 again, we talked about not only the upper limits of safe drinking water quality, but also the lower limits as well. If you're using distillation, you've got to make sure that your water is not too pure that it starts to demineralize your own body when you drink it. Distillation also is quite an energy-intensive process, so you're going to require different ways to generate the amount of heat. So in this picture here, we've got a solar still, and they're using solar energy to heat up that water. If you're doing this, you want to consider how much water can you produce, is it enough for the community, and also what happens if it's raining, or a non-sunny season, would your system still work? Do you have a backup in place? There's also solar panels that are used throughout East Santo. If you look on the EWB website, it shows you the current implementation of solar panels, and have a think about, does the community currently adapt these processes for anything else? Is it widespread? Can you use some of this knowledge to help improve your design? Reverse osmosis. So this uses a pressure gradient to force water through while leaving contaminants on the other side of the membrane. This process is very energy intensive as well, and because it requires a lot of pressure. So if you're doing this, you've got to think about how you can apply enough pressure to get the reverse osmosis to take place. Now these technologies are a bit more complex, so you also need to learn to figure out how to educate your community if they don't understand how these processes work. In reverse osmosis, as you can see in this picture, it's again a multi-step process, and there's a lot of different components that go on. Reverse osmosis, if you're going to do it, because it's such a complex system, you often want to pre-treat it so you don't clog the reverse osmosis membrane, and that's going to be very expensive to replace. Now with this system, because it's quite complex, you want to think about what happens if one part of that system breaks down? Are you able to teach someone in that community how to replace every single component so that one single failure isn't going to stop the entire system? Ion exchange. So ion exchange adds a resin that's additive, and it reacts your ions in the water with H plus and OH. Resins are actually depleted after use, so meaning you have to actually add more resins at certain intervals. If you're doing this, what are your maintenance cycles? How often do you need to re-add those resins in? And how would you enforce this in your community? Who's going to do that job? In ion exchange, we soften the water. So we replace our calcium and magnesium, which are the hard ions, with the sodium and potassium, which are the soft ions. While we think about why you would do this, and if so, do you actually need to soften your water or not? Absorption. Absorption uses a medium to attract organic particles. Now this is similar to the ion exchange in that you need to change the actual medium itself after a while because it is depleted after use. So if you use this technology, you have to think about how often is this technology used, how much water do you filter through, because that changes how often you need to replace your medium. And how would the villagers know when that medium is depleted and they need to change that medium? The last one I want to talk about is disinfection. So this is where you kill off bacteria, similar to what you would do at home, either using chemicals, your sunlight, or you might use heat. If you're using chemicals, where do you get those chemicals from? And how would you remove from the water after it's disinfected? If you're using sunlight, again, what happens if there's no sun out that day? In summary, we talked about a lot of the different technologies that are available. Remember, these are not all the technologies out there, so you will need to do your own research. The purpose of your PIR is to scope out all the existing technologies and consider what is appropriate and how you can apply perhaps not the technology, but the concept behind it. If you're stuck on where to start your PIR, again, these lists of words would be a good place to go, to start Googling and to start your UQ library research. You'd also want to consider, when looking at these technologies, the applicability to your context. Remember, in your PIR, we are looking at a critical review of the literature, meaning we want to see that you understand whether it's acceptable, it can be used, what are the limitations to each of these in terms of Vanuatu, in the Vanuatu context. So think about the materials. Are you able to get the materials? Is the education appropriate there to understand the technologies? Can they fix it? Is it sustainable? Do you need to constantly add things in? If you do need to, can you get more of that additive? And lastly, is your system able to be scaled up so you can apply water treatment to a larger community if it grows?